Good morning, friends. I'm Commander Atul Rohatgi in front of you again. I'm speaking to you on behalf of ISHRAE Institute of Excellence. And as I had told you earlier, that we have started a series of talks, HVAC talks. This part of the series is on psychrometry and part 4. Today we are going to talk about another psychrometric parameter. We have Earlier we have talked about three number psychrometric parameters, that was dry bulb temperature, wet bulb temperature, and absolute humidity. And today's talk is going to be about relative humidity. We read about relative humidity in the atmosphere almost about daily when we read the dry bulb temperature in the newspaper and RH 50% humidity or 60% humidity or 80% humidity or 90% humidity. It is the relative humidity that we are talking about. And relative humidity is the ratio of the actual amount of water vapor present in a sample mass of moisture at a particular condition with respect to maximum amount of water vapor that can exist in the same mass of moisture at the same temperature. And the whole thing is spoken in percentage. So this is what relative humidity is. It is the actual amount of water vapor present per unit mass of dry air divided by the maximum amount of water vapor that can be present in unit mass of dry air at the same temperature, and the whole thing is multiplied by 100 to get RH. In other words, it is also the ratio of absolute humidity at a particular condition divided by the maximum absolute humidity that is possible at the same temperature. The whole thing is taken, the ratio is taken and it is multiplied by 100 to get the relative humidity. By looking at this particular diagram, you can see the psychrometric chart where the x-axis is showing the dry bulb temperature, the y-axis is showing the absolute humidity, and the red dot is showing a particular point that we are talking about. If I draw a horizontal line, it intersects the y-axis at WA, and this WA is the actual absolute humidity at that particular point. If I draw a line that is perpendicular to x-axis starting from the given dot and go up till the point of intersection with the saturation curve, and from the intersection point, if I draw a line that is parallel to the x-axis, this line which is parallel to the x-axis, the point of intersection with the y-axis is called Wm, which is the maximum amount of water vapor present per unit mass of dry air, Wm. If I take this ratio Wa upon Wm, here the Wa happens to be 14.6 grams of water vapor per kg of dry air, whereas Wm is 20.3 grams of water vapor per kg of dry air. If I take this ratio and multiply by 100, it comes to 72, and so 72% is the RH at this particular point. Now, going to the next slide, we can see that there are a lot of concave lines. This the first concave line, concave upward and left, is the saturation curve. The next line is normally 90%, 80%, 70%, and any point on these curves, they are all at 90%. Any point on this particular curve, they are all at 80%. So these are called constant RH lines. Going back, if I read the RH from the curve psychrometric chart, we see that this particular point is a bit above the 70% line, and by eye estimates, we see that it is closer to the 70% line and further away from 80% line. It is around 72% or 73%. And so we can see that the calculated value and the red value with eye estimates, they are quite close, 72% and 73%. So that's all I wanted to talk to you about relative humidity in this particular part of the series. We will be talking about three more psychrometric parameters in our subsequent videos. Meanwhile, if you want to learn more about air conditioning, if you want to join this world, then do join ISHRAE Institute of Excellence. We have a number of courses suited for you. Thank you. Thanks a lot for watching. These are our contact numbers.